Hey guys, our project is transmission line inspection robot. So the idea is to make a robot which can inspect the transmission lines. So maintenance of a transmission line is an important job. This is basically done by humans by climbing on the transmission lines, which are almost 80 meters above the ground, and inspecting this by humans is a very dangerous job. So our idea is to overcome this and design a robot which can reduce human effort and increase human life safety. So the main objectives of our robot are inspection of transmission line and conductors, increase human life safety, decrease human effort, effective and reliable inspection, and to overcome human efforts. So in phase 1, what we have done is we have planned and designed how a robot will do the job and what all things are required. Then we have done some background study of a robot called Explainer, which is the only inspection robot in the world, which is designed by Japan. And we have done some motor load calculations, like what motor to be used, which motor to be used, and we have done kinematics calculations for the performance of kinematics in phase 1, and we have tried sourcing the components in phase 1.
Hello everyone, in phase 2 of our project we have done following things like designing of the robotic parts, 3D printing, assembling, and finally the coding part, and our final output is been achieved after several number of test runs. And coming to the design, the designing of the robot parts are done by using SolidWorks software, and those parts are structures are simulated by using Hypermesh software. And in 3D printing, we have used a material called PLA, which is polylactic acid. It's a thermosetting plastic and a biodegradable one. And finally, the assembly is done, and the wooden wheels are driven by the DC motor arrangements. And the next picture shows the front view of the DC motor enclosure and the stepper motor enclosure, which are mounted on the PVC pipe, which acts as the body of the robot.
Hello, I am Akash Srivastava. I will be providing you with the modularity and the structure of the program of our transmission line inspection robot. So basically, the control unit of the inspection robot or robot is done through Raspberry Pi, which is going to control the 3 independent units, which can be classified into 3. That is, we have motor driving circuit. Then we have the ultrasonic sensor, which detects the location of the robot on the line. Then we have the camera, which basically performs the operation of detecting the fault on the line, which is basically differentiated using the specific colors. So the color, the main function is provided by the camera. So in this, we have defined 3 specific faults for which are differentiated used on the colors. So basically, the camera detects the color, and it mentions the fault which is specified by or linked with the color through us to the screen. So we have 3 basic colors which we have used is red, yellow, and then we have a green. So red color represents the corrosion, whereas the yellow color represents the cracks on the line, and then we have a green color that is basically going to represent the moisture content on the line. So the structure or the modularity of our program starts in this way. Now whenever the program starts, initially it's going to check for the location of the robot on the line. So basically, if the location, that is, it's checking, it powers up the ultrasonic sensor, it checks the distance. If the distance is less than the mentioned distance, then it stops the working of the whole program and it terminates the program. Whereas if it is greater, that is, the robot is far away from the final end point that is to be reached, then it enters the main circuit, or we can say the main code. In the main code, it basically consists of 2 groups. One is we have the motor driving circuit, another one is camera operation. So basically, the motor driving circuit and camera operation are undergoing parallelly as we progress on the line, as the robot progresses on the line. So basically, the camera operation is done by detecting the color. So it acts as a loop. In the loop, it detects the three colors. It detects one or more colors. If it is detected, then it provides the output on the screen. If it's not detected, then it provides that no color has been detected, and it moves to the initial condition of checking the distance of the robot traversing stuff. So, and in between this, the motor will be operating parallelly with a delay of 1 second or 0.5 second. So it is traveling a specific distance of 2 centimeter, 2 to 3 centimeter per second as we are performing the camera operation. So after doing the structuring of the program, we went through a test run for the robot, where in the test run basically we have run the robot on the line while controlling the DC driving motor circuit, where we used it with Arduino. I mean, we controlled it with Arduino, but later we have developed with the Raspberry Pi cores. So basically, we run the robot for a duration of 2 seconds and with a delay of 1 second, and we are running it in forward and backward direction as it can be shown in the video. Then we have the final output. The final output derived from our project is the robot is going to run on the line, and as it is shown. And while running on the line, it also detects the faults from the camera. Okay, while detecting the specified colors, okay, we can say that based on the detection of the colors, we detect the faults. So basically, while the color is detected, then it provides the output on the screen, prompt on the screen, saying that the type of fault detected based on the color with the exact location of the faults on the line. And this is how our robot works, and the final output of our robot. Thank you.
My name is Sumanth, or I will explain regarding the results of the project and the future scopes of our overall project, and also the problem faced while doing the project. So the main thing is, if we had a time, like due to this COVID, we are not able to complete the whole project. So if we had a time, we could have done with some mechanical and kinematics operations has been shown, and we can use the more if we had more budget, and also we can do the accurate model for our whole project. We can also go with the metal parts as we have done the 3D printing in our whole project, and we can also do a better design for our project. So what went wrong is the material which have used 3D printer is COVID-19 lockdown. Like previous 1 month, we were not able to continue our project. So whatever done, but we were able to show all the results in our whole project. And the budget, when we are trying to do it in the home, we didn't have the efficient power supply, the DC power supply. Basically, we had 1.5 amps, but we need 3 amps to draw the whole robot in the the expenditure that we have spent is totally 12,000, and we can see here like how the money has been spent for the overall purchase of the DC motor supply, the stepper motor, and 3D printing material and everything. And we also published our paper in IEEE Bangalore section, and our conference is on May 21st. Our paper was accepted and the payment has been done. The main future scopes of our project is, as the transmission line inspects robot has to pass the obstacle, which is the only drawback, thus creates the necessity of installing high-end drivers and well-gripped wheel with accurate balance. This project is also can be also modified for inspecting single line instead of parallel transmission line. To avoid all the accidents, the robot can be thus manipulated and modified with adding nodes with self-lifting mechanism with the help of propeller. Use real-time image processing for the fault detection. Thank you very much.